All right, so the unit circle really is exactly what we've been doing this whole time. It's just drawing our angles around on an x and y coordinate plane, but we're going to do it for the equation of a circle. Does anybody remember what the equation of a circle would look like with a radius of 1?
Something squared plus something squared equals something squared?
Yeah, which would be in this case 1, because the radius is 1. So the equation of a circle is x squared plus y squared equals the radius squared. But in this case today, we'd have x squared plus y squared equals 1 squared. So again, the reason this is the number that's attached to the x would tell you left or right, but we didn't go left or right, we stayed at 0. The number attached to the y would have told us how far we went up or down for our center. We didn't go up or down, we stayed at 0, so there's nothing attached to the y. And then the radius of the circle is 1, so it's 1 squared. So this circle has an equation of this. It's called the unit circle. And most of the time we don't put that 1 squared there, we just set it equal to 1. Okay, this is called the unit circle. And then over here, it just shows you the unit circle again. It shows you that if you go on your positive x-axis to the point on the side, it would be 1, 0. On the positive y-axis, it would be 0, 1. Negative x-axis, negative 1, 0. And the negative y-axis would be 0, negative 1. So those points are at 1 and negative 1 because of the radius of the circle. Okay, now correct me if I'm wrong, but anytime I draw a radius, what's the length of the radius going to be? It would be 1, right? Because what did we say the radius of the circle was? 1.
But that is clearly not 1, so why is it 1?
Okay, so 1, what are you measuring? I'm measuring radians. Are you measuring little tick marks on your graph?
Yeah.
Yeah. So do you remember the other day when we had the circle that we cut the pipe cleaner for, and we measured the outside of the circle, and you guys decided that we could fit 6.28 of the radians in a circle? And then we talked about the arc length formula, and we decided that if we were going to find the arc length, then we would have to have a radius of 1 if there wasn't a radius shown there for us. Well, this is the same idea. The radius of this circle is 1, so that we can go all the way around with the radius of 1. It's 1 radian that we're talking about here. It's not 1 little tick mark on your graph. Okay? The point being, though, is this. Do you guys see that if I draw the radius, I could then draw a right triangle? I could do it here. I could do it there. Couldn't I do it like anywhere that I draw a radius? Like literally anywhere I draw the radius, I could make a right triangle with it, right? So that's what they've done to form the unit circle. So what we've been doing with other points on the graph, they've completely done with the unit circle. And they have a unit circle like somebody's done it and filled it out for you, so you can just kind of look at it and read it. Okay? So I'm going to give you a really nice copy of this in a little bit, but here's what it's done. It's taken all of these triangles, and it's found the cosine and the sine. Because do you remember when we said the other day that the cosine is what value? The x value. The sine is what value? The y value. And we actually said when we did this, we said it was x over r, and we said it was y over r. But what did we say the r value is going to be in this example of the unit circle? The r value would always be 1 because the radius is 1. So in the unit circle, the cosine value is just x. In the unit circle, the sine value will just be y. And in the unit circle, the tangent value will still be y over x because we'll still have values for all of those. So when we look at our unit circle, if I asked you to find the cosine of 90 degrees, you would go to 90 degrees, which is right here, and the cosine would be the x value, which would be 0. So the unit circle has the sine and the cosines completely figured out for you for every circle or every triangle you can form in the circle with a radius of 1. Okay, so it's kind of like where all trig functions come from is from the unit circle, and then what we've been doing the other few days is when we extend that unit circle to be a bigger circle than a circle with a radius of 1. So again, here we're going to do an example of how to do this. It says find the exact value of the sine of 135. So I'm going to go to 135 degrees, which is marked for you up here. Do you see how they have 135 degrees marked? And I need the sine. Does anybody remember what value I said the sine was? The sine is the y value. So grab the y value in that ordered pair that's formed at that angle. And what is the sine of 135 degrees equal to? It's equal to the square root of 2 over 2. Okay, we literally go to the x and y value and just grab the y value off of the unit circle. Okay, hardly any math involved. All right, next example, find the cosine of 4 pi over 3. So they only gave you the quadrant that 4 pi over 3 is in, but if you go and you find 4 pi over 3, it's right here. And I'm doing the cosine. So the cosine of 4 pi over 3 is the x value, right? So read that x value right there, and what do you get for your cosine? A negative 1/2. Okay, so really today's math is learning how to read a chart that's made from all of the angles in a circle with a radius of 1. Okay, next example, what's the exact value of the tangent of 330? Let's just remind you that the tangent is y over x, which means I'm going to have to find my y and divide it by my x. So a tiny little bit of math here. But let's go and find 330 degrees. It's marked on my chart for me right here. I'm going to do my y value, which is a negative 1/2, over my x value, which is the square root of 3 over 2. And I can't really leave it that way. Does anybody remember what I do when I have a fraction divided by a fraction? I flip the second fraction upside down and multiply instead, right? It's called multiplying by the reciprocal. So instead of having 1/2 divided by the square root of 3 over 2, I'm going to have negative 1/2 times 2 over the square root of 3. Right? Do you see how I just flip this one upside down and I multiply by it instead? You guys remember that, right? Multiplying by the reciprocal. So on the top, because top times top, I get negative 2. And on the bottom, I get 2 square roots of 3. Now, I would love to be done right here, but you know I can't leave a square root on the bottom. So you could totally simplify this right now and then get rid of that square root on the bottom. Or you could just punch it in your calculator the way that it is. So turn your calculator on and do on your fraction. Just do a negative 2 on the top. Do 2 square roots of 3 on the bottom. Hit enter and it will reduce it for you. So you have negative square roots of 3 over 3 for your solution. Anybody have a question on how I did that? Again, it's really just reading the chart, right? Find your y, find your x, and do your division. Really, if you wanted to right here, could you have punched it in your calculator right there? Yeah, you could have. Your calculator's smart enough to do that for you. All right, last example right here. It says to find the sine of pi 6. Just to remind you, the sine value is your y value when you find it. So you got to find pi 6 on your chart. Pi 6 is right here. You're finding your sine value, which is your y. So it's 1/2 for your solution. That's how you read the unit circle.